Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss formation of phenol or preparation of phenol. Last class I have discussed preparation of alcohol. Now I am going to discuss preparation of phenols. Phenol, also known as carbolic acid, was first isolated in the early 19th century from coal tar. Nowadays, phenol is commercially produced synthetically. In the laboratory, phenols are prepared from benzene derivatives by many methods. I will tell few methods. First, from haloarenes. Haloarene means chlorobenzene. Then how will you get phenols from chlorobenzene? I am telling you now. Chlorobenzene is fused with NOH at 623 Kelvin and 320 atmospheric pressure. Phenol is obtained by acidification of sodium phenoxide, so produced. Reaction I am telling you, chlorobenzene means in benzene one chlorine is attached plus NOH. It forms ONA, actually NaOH. Then NaO minus H is plus. Then Cl is minus. Then NaO is also minus, Cl is also minus. Hence NaO will substitute Cl, means Cl will go out, in its place NaO will come. Then O will join with carbon. In the beginning Cl was joining with carbon. Now NaO has come, then O will join with carbon and it will form ONA. Then O will have negative charge, Na will have positive charge. Now after acidification of sodium phenoxide means ONA, this ON is attached with benzene, that's why it is called sodium phenoxide. Then from this sodium phenoxide on acidification means in the presence of HCl, it will give phenol, because Na from phenoxide, sodium phenoxide, and Cl from HCl, that will go as NaCl and H will go with O. Then O became now OH, because Na went as Na plus. Then in the place of Na plus, H plus will go, H plus. Then now it formed OH, that is a phenol. And Na went with Cl minus, Na plus Cl minus. It went as NaCl. Now second method I am telling you, from benzene sulfonic acid. From benzene sulfonic acid. Benzene is sulfonated with oleum. Oleum means H2S2O7. When it will break, it will give H2SO4, one molecule H2SO4, and one molecule will go, it will give this things H2S2O7. It will break into two. It will break into two, H2S2O7. It means what? Just it will give SO3H, and rest remaining will be H2SO4. H2SO4 because 7 oxygen is there. Then 3 oxygen came with HSO3. And this H actually it will give as HSO4, HSO4 and HSO3. It will give H2, S2O7. Then divide into two parts. Then one part will be HSO4, HSO4. Another part will be HSO3, HSO3. Correct? Then now this HSO3, that is positively charged. HSO3 is positively charged. And in benzene, one H will go and in its place HSO3 will come. Means S will join with carbon, HSO3. Then S will join with carbon and it will form benzene sulfonic acid. Benzene sulfonic acid. And this H plus which went from benzene, that will go with HSO4. HSO4 is minus. HSO4 is minus. Then this H plus from benzene, it will go to the HSO4 minus. Then now it will form H2SO4. Correct? This is the important step I told you. Now you got the benzene sulfonic acid. Now how will you get from benzene sulfonic acid? How will you get phenol? Phenol from benzene sulfonic acid. This is a complicated step. You can't understand directly. I am telling you directly from benzene. From benzene you got sulfonic acid. Correct? How did you get? I told you. Now from sulfonic acid you will get phenol. How? This is a complicated step. Okay, but I will tell you, you will understand. Then this conversion of sulfonic acid to phenol, one step will come, that is the sodium, that will come benzene sulfonic. After benzene sulfonic acid, you will get sodium phenoxide. One intermediate you will get. From sulfonic acid you will get sodium phenoxide and then you will get phenol. Okay, then sodium phenoxide, how will you get? Actually you can write directly, with benzene SO3 is attached, directly you can write phenol. But I am telling you how will you get phenol, because group is SO3H. How directly it converted to OH? Phenol. This is important things. Then I am telling you that in the middle one product will form, that is a sodium phenoxide will form. Then you will ask how sodium came here. Sodium phenoxide means ONA. ONA is joined with benzene, then it is called sodium phenoxide. Sodium phenoxide. Actually benzene, when benzene will join with O, and O will have negative, one negative. That's why Na can come there. Then O minus Na plus. That is called sodium phenoxide. Now question arises, how sodium came here? How did sodium come here? Then here actually requirement is after sulfonic acid, benzene sulfonic acid, to convert or to get phenol, NOH is required. Sodium hydroxide is required. And after that acidification will be done. Okay, two more step is there. Then first you understand that how you will get phenoxide, sodium phenoxide. It means sulfonic acid, benzene sulfonic acid will react with NOH. NOH. Then NOH, when NOH will react, then Na is positive charge, and in SO3H, benzene sulfonic acid, SO3H, H is positive, hence H plus will go and Na will come there. Then you will get SO3Na, SO3Na, and in NOH, OH was there, and now this H plus, it will form water. Then now you got SO3Na. Now after that what you have to do, again reaction will take place with NOH. NOH. You consider 2 NOH. Then what will happen? Now actually you have to remove this SO3Na. SO3Na you have to remove. Then how will you remove, or how it will remove? Then for that purpose, means actually more NOH is required. One you can say NOH role you have seen that now it became SO3Na. But now NOH is again role. 2 molecules further, that's why it is taken in more quantity. Then now 2 NOH suppose you have taken further, then now this SO3Na will go as Na2SO3. Na2SO3 means here SO3Na plus, from the 2 NOH you have taken, from that 1 Na plus will go there. Then actually SO3Na plus this Na, it will form Na2SO3. It will form Na2SO3. Correct? And after that, what will happen? What will remain? Na gone. Then now 2 molecule was there. Then 1 Na only went. Then now here ONA is remaining. ONA is remaining. Then that actually ONA, which is negatively charged, ONA, correct? That will go there with benzene, and it will join there as a ONA, correct? Then now you can say what will happen, that ONA, which is negatively charged, joined with benzene, ONA, and now this SO3Na plus 1 more Na sodium, it formed Na2SO3. Actually SO3 is having 2 negative charge, correct? Then that's why here that this SO3 bond will break, SO3 bond will break, then it will take electron, then that electron when it will go by leaving the electron, then that electron will be given to sodium, and it will form Na2SO3, correct? Then now this SO3 Na, it went by taking the electron. Then now that carbon became positive. Then here ONA, O is negative charge, that O will join with that carbon and it will form ONA. ONA, correct? That is a phenoxide, sodium phenoxide. Now you got sodium phenoxide easily, and this SO3Na, one negative was there, that joined with one Na plus, and it went as a Na2SO3. And now you have taken 2 NOH, then both Na used up and 1 oxygen used up. But now 2 hydrogen and 1 oxygen is remaining, because it was 2 NOH. Then both sodium used up and 1 oxygen used up. Then now 2 hydrogen and 1 oxygen is remaining, that will form water, H2O. Then now anyhow you got ONA, sodium phenoxide you got. Now on acidification, that HCl, as for example HCl, then Na and Cl will form NaCl, correct? And this ONA was there, Na is positive charge, and HCl, from the HCl H plus, that will come, that will substitute with Na, means Na plus will go and H plus will come, then it will form phenol, and Cl minus and Na plus, that will form NaCl. Then now you got phenol. That acidification can be done with H2SO4 also. Okay. Then now I told you that this production of or preparation of phenol from benzene, or you can tell benzene sulfonic acid. What I told you, very important reaction I told you, because directly from benzene question is asked how will you get phenol. Then from benzene, with the help of oleum, you will get sulfonic acid. Benzene sulfonic acid you will get. This step is called sulfonation. And after the sulfonation means from benzene sulfonic acid you will get phenol. But in the middle 2 steps I told you. Main step is phenoxide, formation of sodium phenoxide, and after that acidification with either HCl or H2SO4. Then you will get phenol. In the middle, sulfonic acid, between the sulfonic acid and phenol, 2 steps are there. First phenoxide and then again acidification. Then you will get phenol. That you will study in mechanism, but mechanism already I told you. Now third method, that is the from, you will get phenol preparation. You can get phenol from diazonium salt. Then diazonium salt, what do you mean by that diazonium? Here you will get N2 plus Cl, 1 Cl, that is actually salt. Cation and anion, that is salt, like NaCl, plus and minus, salt. Like that way, here you will get that N2 will be positive charge, and because it has a positive charge, then it can attract Cl, 1 minus. Then if this salt is attached with benzene, if this N2Cl is attached with benzene, then it is called benzene diazonium chloride. Okay, means with benzene N2Cl is attached, but here N2 you have positive charge. N2 have positive charge, 1 positive charge, and Cl is 1 negative. and this N2Cl N has joined to the benzene ring. Then it is called benzene diazonium chloride. The word di has come due to N. Okay. Then now how will you get benzene diazonium chloride? First I will tell you. Then from benzene diazonium chloride you will get phenol. Okay. Then now I am telling you, this question is also very, very important. I am telling you details. A diazonium salt is formed by treating an aromatic primary amine with nitrous acid. How will you get nitrous acid? Then in C2 means during the reaction you will get NaNO2 plus HCl. You will get HNO2, that is the nitrous acid. But here temperature requirement is there, that is around 278 Kelvin, between 273 to 278 Kelvin. NaNO2 plus HCl, during the reaction you will get HNO2, that is called C2, SiTu. Then a diazonium salt is formed by treating an aromatic primary amine with nitrous acid. Diazonium salt are hydrolyzed to phenols by warming with water or by treating with dilute acids. Then here primary amine, aromatic primary amine, you will get it from aromatic primary amine only. Okay. Then here example of aromatic primary amine is aniline. Okay. Means in with benzene ring NH2 group is attached. Then you want diazonium, means 2 nitrogen you want. Then here 2 nitrogen will attach to itself between the triple bond. Triple bond will be there between N and N, you remember. Then now aniline, NH2 is attached with benzene. Then now what will happen, that when it will react with HNO2, that you will get from NaNO2 plus HCl. Okay. Then this NO2 will attach to the NH2 of aniline. Then here these things, important thing is that how we will get N2, that you have to understand. HNO2. Then now this with aniline 2 hydrogen is there. Okay, 2 hydrogen is there. Now to make a bond with another N, 3 bond is required. Then anyhow NH2 is there, then this 2 bond is there, that bond will break. Then now suppose when bond will break, just for understanding purpose, just to understand that 2 bond will be 2 electron will be available. Okay, 2 hydrogen will go with one electron. Just simply you understand. Actually here nitrogen is more electronegative than hydrogen. Then nitrogen will be with this electron will be with nitrogen only. Both hydrogen will go as a H plus, and both electron given by hydrogen will be with nitrogen. Correct? Then two electron will be with nitrogen, and this 2 hydrogen will go as a H plus. Now you can see what will happen, that nitrogen has one lone pair also. Nitrogen has one lone pair also, means on nitrogen now 4 electrons are available. 4 electrons are available. Then now the total 4 electrons are there. Then now when this NO2 will come, HNO2 when it will come near that, then what will happen? That NO2 will also break. 2 oxygen is there. Okay, 2 oxygen is joined, NO2, and this is actually HNO2 is there, HNO2. Then when two oxygen is joined with double bond, then if bond will break, if in a simple we understand, if a double bond will break, then both will take 2 electron. First we understand in a simple way, then ion wise obviously we will understand. Then double bond will break, then 2 electron oxygen will take, and 2 electron nitrogen will take. Correct? Because in double bond 4 electrons are there. 4 electrons are there. Then 2 electron oxygen will take, 2 electron nitrogen will take. Other double bond will, if breaks, then again 2 electron nitrogen will take, and 2 electron oxygen will take. Then now nitrogen has 4 electron. 4 electron. Correct? Then after that what will happen? That this is I told you about the HNO2. Now 4 electrons are with nitrogen, and with that H is attached. H plus is attached. Then now what will happen here? That this NO2 will, when it will come with nitrogen, means aniline, then now first they will make sufficient electron is now there. Sufficient electron is there to make the bond, triple bond, because that 4 electron is with nitrogen, and here also 4 is there with this nitrogen also. Correct? Then first they will make triple bond, then N2 is formed, but now both will have electron. Nitrogen also have both nitrogen now extra electron they have. Then now what will happen? That now N2 is formed. Then here what will happen? Actually this reaction takes place in the presence of NaCl and NNO2. That's why it is forming HNO2. Then now 2H is without electron. 2H is without electron. Correct? Means they gone as a H plus and H plus. They require electron. Then now 2 electron will be given to that H. Then now only 2 electron is remaining with nitrogen. 2 electron is remaining with nitrogen. Correct? then now this 2 electron is remaining there, then now it can make the salt. If chlorine is there, then it can donate that lone pair of electron to Cl. Then it will form salt N2Cl. But now here that NO2, that O2 has to go. Then this first we understood that how bond formed. But now oxygen, 2 oxygen is there and both have only one, you can say both 2 electron, both oxygen have. Then what will happen to this oxygen? 2 oxygen is there, then what will happen? Then now actually this oxygen can make, with 2 hydrogen is there and 2 oxygen is there. Then now it can form water, H2O. If more hydrogen is there, now I am discussing only with 1 molecule of aniline. Now suppose this aniline is more quantity, the more hydrogen it will release. Correct? Then when here hydrogen will be more, it can join with water. It will form H2O. Then 2 oxygen is there, then 4 hydrogen is required to make 2H2O. And HNO2 also have one, when it will this leave the this HNO2, when it will come in the form of only NO2, then that also it will leave as H plus only. Leaving the electron, it will leave as a H plus. That also require electron. Then here actually you will get from aniline, you will get benzene diazonium chloride. Okay. Here also mechanism made little difficult, but I am telling you how you are getting N2. For that purpose I told you 2 hydrogen is NH2, means these 2 bond will break, and these 2 bond, when it will break, then N will get 2 electron, because hydrogen will go as a H plus, 2H plus, and that 2H plus will convert into oxygen. This react with oxygen from NO2, and it will form water. 2 oxygen is there, then 4 hydrogen is required to make water. Okay. Then now here when NO2 will approach to the NH2, then now this electron which hydrogen left and gone, then 2 electron is there, and or you can tell it will have 2 negative charge, because hydrogen will go as a H plus. Then now nitrogen, that bonds actually breaks NO2. Actually in NO2 also, if you will see the these things structure, then you will find that N and O double bond is there with 1 oxygen, and with other oxygen only 1 single bond will be there. But resonating structure time, where double bond was there it will become single bond, and where single bond was there it will become double bond. Means resonating structure you will get, double bond character you will find. But there actually 3 electrons are there, 2 plus 1, 3 electron is there. Correct? Then that when this bond will break, then you will get only 3 electron. Okay. It is making double means alternate, sometimes double bond, sometimes single bond. Resonating structure you see. One oxygen double bond, other single bond. Another, and in other structure where double bond was there, that will single bond. Other bond will be double bond. Correct? Then actually 3 electron is there. 3 electron is there. Then that 3 electron, and here NS2, that 2 bond broken. 2 bond broken, then 2 electron, and 1 electron it can take from the lone pair of electron. Nitrogen has lone pair of electron. Then 3 electron of this nitrogen, 3 electron of that. It will make N2. And on this on aniline nitrogen, now 1 electron is remaining. That it can give to the Cl, chloride ion. Correct? Now it is actually N plus. It become N plus. Correct? Then now what we are adding N2 plus, then N2 plus is due to this only, because that 1 electron will be given to the chloride ion. That's why it will form that it will form actually this thing N2Cl, that is called diazonium chloride, and this is attached with benzene. It is called benzene diazonium chloride. Okay, and these things after this, after getting benzene diazonium salt, easily you will get phenol. You wanted phenol, then for that you have to warm it with water. Then in that situation what will happen? Water means OH. OH will be there and H will be also there. H plus OH minus. Then now this H plus and Cl minus, N2Cl is there, then that Cl and this H plus will form HCl. Actually N2Cl bond will break. N2 which was making bond with carbon, that bond breaks. And when it will break, then it will take the electron and then it will go. N2 was having positive charge, and Cl attached. It was N2Cl. Then this N and C bond is breaking. When this bond will break, then nitrogen will go by taking its electron. And then carbon will become positive. Carbon will become positive. Then now all bond is breaking. N2 and carbon bond is breaking. N2 and Cl bond is breaking. Means all will be free. And this N2Cl will break into N2, nitrogen gas, plus HCl. Side product will be N2, nitrogen gas, plus Cl. It's HCl. And now H plus and Cl minus, that will form HCl. Then now there, because carbon is positive, then now it requires negative, then OH will go there from water, OH. It will join there. When N2 and carbon bond broken, that time carbon got positive charge, and OH minus from water, H plus OH minus, then H plus went with Cl minus, formed a Cl, and this OH minus will come to the carbon, positive carbon, and it will form phenol. Okay. Then benzene diazonium chloride, on treatment with warm water, it gives phenol plus N2 plus HCl. Okay. Now next preparation I am telling you from cumin. What is the formula for cumin? Now actually cumin means this from benzene. Actually you can understand like that. With carbon, suppose 3 methyl group was attached. With carbon, 3 methyl group was attached. Just to understand these things. CS means in the middle, carbon was there, and again one alkyl group, other alkyl, 3 alkyl group was there, methyl, methyl, methyl. Correct? Now from that actually, then actually when we are seeing that this situation is like a propane situation, propane that CH3, CH2, CH3, CH3, CH2, CH3. Then this CH2 middle carbon that will join with benzene carbon. This will join with benzene carbon. Correct? Then central metal carbon will have only one hydrogen. Only one hydrogen. Hence, now cumene structure will be with benzene. This actually propylene group is attached. Propylene means middle carbon has one electron hydrogen less, CH only. Okay, CH only, that CH will join with benzene. Then that will be called cumene. Means for propylene, when it joins with benzene, then it will join with middle carbon, central. Okay, CH3 in the middle, CH2 was there, but one H gone. As a H plus, then that carbon will have negative charge, and benzene, where it gone, H gone, carbon, that benzene ring also has a H. Then here actually that CH2, from that one H, and from benzene ring one H will go. Then both H, actually this will happen only in presence of oxygen. Only in presence of oxygen, means oxidation will take place. Then for the oxidation, hydrogen is required. Then one hydrogen from propane and one hydrogen from benzene ring, and oxygen is there, it will form H2O. Then now problem is solved, that propylene group will join with carbon of the benzene. Then it will form cumene. Okay, suppose cumene structure I am telling you, simply propylene is attached to the benzene ring, then it is called cumene. Then phenol is manufactured from the hydrocarbon. What is hydrocarbon? Then cumene. Then with cumene structure means now propylene group is attached, CH3, CH, CH3, that group is attached with benzene, that is called cumene. Then phenol is manufactured from the hydrocarbon. What is which hydrocarbon? Then cumene. Cumene, that is also you can tell isopropyl benzene. When cumene is oxidized in the presence of air, to cumene hydroperoxide, it will form cumene hydroperoxide on oxidation. Cumene on oxidation, it will form hydroperoxide. Okay, means now the H2O2 is peroxide, then only one H will go, then 2 O and 1 H is there. Now that O will be negative, then it will join to the positive carbon, because from that carbon H will go as H plus, then C will have these things, peroxide is there now, peroxide, then 1 O. Here actually that you can consider that hydrogen gone with 1 electron, then on oxygen 1 electron is remaining. Then that CH bond of cumene, when it breaks, again you understand like that way, 1 electron hydrogen is taken, 1 electron is with carbon. Then now this electron of carbon, one electron of carbon, one electron of oxygen. It will make the bond and it will form cumene hydroperoxide. Cumene hydroperoxide. Okay, in a very easy way I have told you. And from this cumene hydroperoxide, this is called cumene hydroperoxide. After that, what will happen? That here that bond will break. Actually, that here OO bond is there, that bond will break. O and H peroxide which has joined, H2O2 was there, then H gone down, H after going H, 2O was there and 1 H was there. Then bond between O will break. Then when this bond will break, then OH bond will be free. And this CH3, with that one oxygen is attached, because oxygen was attached to the carbon. Then oxygen bond is breaking. Then it will form actually acetone. And because this when bond will break OO, then one electron will be free. Or you can tell here that this when it bond breaks, then both electron will be taken by oxygen. Then it will form a double bond, CO. Actually, here complete two bond is breaking. First bond it is breaking, that carbon and benzene carbon, propylene carbon and benzene carbon, where it is joined, that bond is breaking. Correct? Then one electron carbon will get from there, and one electron, because OO bond is breaking, then that electron and this electron, they can make one bond. Hence carbon and oxygen, already one bond was there, CO. Now that bond will come double bond, CO means acetone. One product will be acetone. Correct? Now OH is free, that have one electron, because one electron, suppose it has taken, in one bond 2 electron is there, then OH is having one electron, and this carbon, propylene carbon and benzene carbon, when broken, then carbon was having one electron. Then that one electron and OH one electron, they will make bond. And OH will be attached there. OH will be attached, means you will get product phenol, and other product will be acetone. Correct? Then easy method I have told you. And charge wise also you can understand. Always you think that oxygen will take the negative electron and it will become negative, because oxygen is electronegative. Charge wise also you can understand positive and negative. Okay, positive charge, negative charge, that way also you can understand, keeping in mind that oxygen is electronegative, it will take the electron. Then when it will take the electron, it will be negative, and that carbon will become positive. Okay, this if you will understand like this, then charge wise also you can understand. Okay, because in that situation what will happen, when bond will break, then OH will get, OO bond will break, then what will happen, OH will get negative charge, then carbon will have positive charge, benzene carbon, there it will attached. It means that propylene group will have negative charge. Then that negative charge means when complete bond is breaking and electron is taking, then that time they will have 2 electron. They will not share. Sharing generally will take in the presence of UV light. Only in presence of UV light radical formation will be there. For understanding purpose I have told you, but charge wise also you can understand that propylene will become negative, then that carbon will become positive, and then carbon will become positive, benzene carbon, then OH which is negative, that will join. And because propylene carbon has a negative charge and C and O, CO, one single bond is there, and then carbon has now double bond, anion condition is there, carbanion, then that will give to, they can make one more bond between carbon and oxygen, because that time oxygen will try to take that electron, because its electron is taken by OH, that O has taken its electron, that's why that time O became positive, O became positive, that's why this carbon anion have negative charge, means 2 electron it was having, that will be taken by that oxygen, hence now carbon oxygen bond will be double bond, it will make double bond between carbon and oxygen, then it will form acetone, and other product, main product will be phenol. Okay, then now I have discussed the these things, preparation of phenol. Now I want to tell you physical properties of alcohol and phenol. Alcohol and phenols consist of two parts, an alkyl or aryl group, one alkyl group, other aryl group. That is, if alkyl ethyl alcohol is there, then one part is alkyl, other is alcoholic group. If phenol is there, the one will be aryl group, other will be phenolic group, OH group, hydroxyl group. Alcohols and phenols consist of two parts, an alkyl oblique aryl group and a hydroxyl group. The properties of alcohols and phenols are chiefly due to the hydroxyl group. The nature of alkyl and aryl groups simply modify these properties. Now, boiling points. The boiling points of alcohols and phenols increase with increase in the number of carbon atoms. Why? Because increase in the van der Waals forces. In alcohols, the boiling point decreases with increase of branching in carbon chain. Why? Because of decrease in van der Waals forces with decrease in surface area. Question is asked. Why boiling point decreases? Boiling point decreases with increase of branching in carbon chain. Branching in carbon chain because of decrease in van der Waals forces with increase in surface area. The OH group in alcohol, and phenol is involved in intermolecular hydrogen bonding. C2H5 is there. Suppose it is C2H5. OH is there. Another C2H5 is there. And that also have OH. Then first hydrogen bonding will take place, because C2H5 OH, I mean CH3 CH2 OH. Then this H of first molecule and O of second molecule of ethyl alcohol, they will attract to each other and it will make a bond, weak bond. Correct? Means for every alcohol, many alcohol molecules are there. Then every alcohol's oxygen will have negative charge and hydrogen will have positive charge. Then oxygen of the first molecule and hydrogen of the second, which is positively charged, both will attract to each other and it will make hydrogen bond. That bond will be very weak bond. Like that way, second and third. Second, you can say oxygen of the second H, a second you can say alcohol, and hydrogen of third molecule of alcohol. Again they will join. Like that way third and fourth and fifth and sixth. Like that way all can join to each other. Then it will take more, you can say, this temperature to break the bond if you will boil it. Okay. The OH group in alcohols and phenols, same way phenol also, it will join to itself by hydrogen bonding. Same way. Correct? And due to this, we can say, due to this reason they are liquid. Phenol is also liquid and alcohol is also liquid due to this hydrogen bonding. It is interesting to note that boiling point of alcohol and phenols are higher in comparison to other classes of compounds, namely hydrocarbons, ethers, haloalkanes and haloarenes of comparable molecular mass. If we will compare, then phenol and ethyl alcohol, their boiling point will be more, because here hydrogen bonding is going on, but in other it is not like that. Okay. Then boiling point of alcohols and phenols are higher in comparison to the other classes of compounds, namely hydrocarbons, ethers, haloalkanes and haloarenes of comparable molecular masses. For example, ethanol and propane have comparable molecular mass, but their boiling points differ widely. Okay, the boiling points of methoxymethane is intermediate of the two boiling points. Okay, then here example I am telling you. Suppose now ethanol is there. Ethanol, CH3 CH2OH. Ethanol, its molecular mass is 46. Molecular mass is 46 and boiling point is 351. But methoxymethane means CH3O, CH3. Acetone you can tell. CH3O, CH3. Not as this ether. Methoxymethane, that is the ether. O is attached with 2-methyl group. Okay, it is methoxymethane, ether. Then now its molecular mass is 46, but boiling point is less, 248. Then see, both have ethanol and methoxymethane. Molecular mass is 46, but boiling point for ethanol is more. Boiling point of ethanol is 351, but here boiling point is 248, and this is happening due to hydrogen bonding in ethanol. Okay, and propane also you can take example. Its molecular mass is 44. Roughly you can say 46, 44, not too much difference, but there is a more difference in boiling point. Boiling point is 231 for propane. 231, molecular mass is 44, but boiling point is very less, 231. Correct? The high boiling point of alcohols are mainly due to presence of intermolecular hydrogen bonding in them, which is lacking in ether and hydrocarbons. Now, solubility. Again, this hydrogen bonding is responsible. Solubility of alcohol and phenols in water is due to their ability to form hydrogen bonds with water molecules. The solubility decreases with an increase in size of alkyl or aryl or hydrophobic groups, you can tell. Okay, hydrophobic. Aryl, that is the phenol group, that is hydrophobic actually. The solubility decreases with increase in size. If size will increase, then solubility will decrease. Okay, solubility decreases with increase in size of alkyl or aryl groups. And several of lower molecular mass alcohols are, but if size is small, means lower molecular mass of alcohol are miscible with water in all proportion. If alcohol is of less molecular mass like methyl alcohol, ethyl alcohol, then several of the lower molecular mass alcohols are miscible with water in all proportion. Okay. Then now I have discussed about the this physical properties of ethyl alcohol, means you can tell alcohol and phenol. Okay. Now I am stopping only here. Next class I will discuss chemical reaction. Thank you.